angle between the lines in 3D space. Let's say we have two lines, line 1 and line 2, L1, L2. Now the direction cosines are L1, M1 and N1. Similarly, direction cosines of line 2 are L2, M2 and N2. Now let theta be the angle between the lines. So let's draw so you have, this is O, this is P, this is Q, right? Now these two lines make an angle theta. The unit vector along L1 and L2, let's say they are, unit vector A is equal to L1I plus M1J plus N1K, and B is equal to, unit vector B is L2I plus M2J plus N2K. Okay, now remember, to find the angle we require a triangle, right? So let's add this line. Now this line is going to be what? This line is going to be OQ minus OP. Remember, position vectors would be position vectors of P and Q are what? OP and OQ. PQ would be equal to OQ minus OP. This is not a right angle triangle, so we can't use our normal trigonometric ratios. What we'll have to do is we have to use the cosine rule. Now what does the cosine rule say? Cosine rule says cos theta is equal to OQ OP divided by OP OQ, and here remember OP not equal to 0, absolute value of, and absolute value of OQ not equal to 0. Keeping this in mind, if we look at the unit vectors L1 and L2, cos theta would be equal to, remember we are talking of unit vectors, so A hat B hat divided by magnitude of A hat and magnitude of B hat. A hat is nothing but L1I plus M1J plus N1K, L2I plus M2J plus N2K divided by, remember this would be 1. Magnitude of A, because it is unit vector, it will be 1. Similarly for B also it will be 1. Now let's multiply the numerator. Now when we multiply the numerator, what happens? L1 L2 I times I is 1, right? Now similarly L1 M2 I times J. Now I times J is 0. Similarly I times K is 0. So this is what you would end up with. M1 M2 plus N1 N2. Now here remember I times I is equal to 1. J times J equal to 1. K times K equal to 1. I times J equal to 0. K times J is equal to 0. And finally I times K equal to 0. Cos theta would be equal to L1 L2 plus M1 M2 plus N1 So we can say the angle between two lines would be equal to the cos inverse of the sum of the products of the respective direction cosines. Now let's look at in terms of sine what it will be. So sine square theta is equal to 1 minus cos square theta. We know this. Okay. Now 1 minus, we know cos theta. So L1 L2 plus M1 M2 plus N1 N2 square. We know L1 square plus M1 square plus N1 square is 1. Right? So we can substitute 1 with this. But then we also require the other line as well. So we include that also. L2 square plus M2 square plus N2 square. Now this is 1, 1 times 1 is 1. Okay. Plus M1 M2 plus N1 N2 square. Now this would become a little bit tedious, but take it step by step. Let's multiply these two. L1 square L2 square plus L1 square M2 square plus L1 square N2 square. M1 square L2 square plus M1 square M2 square plus M1 square N2 square plus N1 square L2 square plus N1 square plus N1 square M2 square plus N1 square N2 square. Now when we expand this, every term in this result would be negative. So minus L1 L2 square minus L1 L2 M1 M2 minus L1 L2 N1 N2 minus M1 M2 L1 L2 minus M1 square M2 square minus M1 M2 N1 N2 minus N1 N2 L1 L2 minus N1 N2 M1 M2 minus N1 square N2 square. Now L1 square L2 square L1 square L2 square M1 M2 square M1 M2 square and N1 N2 square N1 N2 square. Okay, now apart from that, if you look at this L1 M2 and L1 M2, see whether you can L1 M2 and L1 M2 this and M1 L2. Can you see that? M1 L2. Now look at these four. These two just directly gets added up. So let's write it. It's better to write one additional step than get confused later on. Plus M1 square L2 square minus 2 times L1 L2 M1 M2. Okay. Similarly, you will have L1 square N2 square plus N1 square. Let's keep L first. L2 square N1 square minus 2 times L1 L2 N1 N2 and finally one more M1 square N2 square plus M2 square N1 square minus 2 m1, m2, n1, n2. Now look at this. This can be written as the first three terms can be written as L1 m2 minus m1 L2. Again, let's put L first. L2 m1 square. If you expand it, you will get back this L1 square m2 square plus L2 square m1 square minus 2 times L1 L2 m1 m2. So now this is just a repetition of the same pattern. L1 n2 minus L2 n1 square plus m1 n2 minus m2 n1 square. This is nothing but sine square theta. So sine theta would be what? The square root of this entire expression. In short, we can write this as square root of L1 m2 minus L2 m1 square. Remember, this is the notation where we keep substituting. So L1 m2 minus L2 m1 square plus, in place of L1 we write m1, in place of m2 we write n2 minus m2 n1 square again. So this is, we learnt it as part of modular mathematics. Okay, now that is in terms of sine theta. Now let's look at it in terms of direction ratios. Now if A1, B1, C1 and A2, B2, C2 are the direction ratios, then we know L1 is equal to A1 by A1 square plus B1 square plus C1 square. Okay, now we know cos theta is equal to L1 L2 plus M1 M2 plus N1 N2. Just do the substitutions. Right? When you do the substitutions, L1 times L2. So now what happens? A1, A2. And we multiply the denominators also. If you notice, denominators are same for L, M and N. So we can combine them, because anyhow afterwards we'll have to add it. So when we add it, we have to take the LCM, and since they are all same, LCM will be same. So A1 square plus B1 square plus C1 square times square root of A2 square plus B2 square plus C2 square. Now A1 times A2 plus B1 B2 plus C1 C2. That's the expression for finding cos theta in terms of direction ratios. Remember, we are talking of lines. So two special possibilities are that the two lines are parallel. Now if two lines are parallel, then theta equal to 0. Now if theta is equal to 0, sine theta is equal to 0. Okay, remember that circular thing. So L1 M2 minus M1 L2 square plus M1 N2 minus N1 M2 square plus N1 L2 minus L1 N2 is equal to 0, because this is nothing but sine theta, and sine theta is 0. Now if the sum of three things is equal to 0, that means each one of them also have to be 0. So L1 M2 minus M1 L2 equal to 0. m1 n2 minus n1 m2 is equal to 0, and n1 l2 minus l1 n2 is equal to 0. All the three have to be true. Now this implies m2 is equal to m1 l2. This implies m1 n2 is equal to n1 m2. This implies n1 l2 is equal to l1 n2. Again, if we take this further, it means L1 by L2 is equal to M1 by M2. This is equal to. This implies M1 by M2 is equal to N1 by N2. This implies N1 by N2 is equal to L1 by L2. So we can combine all of them. L1 by L2 is equal to M1 by M2 is equal to N1 by N2. Now we also know L square plus M square plus N square is equal to 1. So if we square individually each one of them and add them up, then we would end up with 1. So let's do that. This would be 1. 1 by 1 equal to 1. So which means L1 by L2 equal to 1, M1 by M2 equal to 1, N1 by N2 equal to 1. Now this means L1 is equal to L2, M1 equal to M2 and N1 equal to N2. What does that mean? That means that the direction cosines are equal if the lines are parallel. Now what about direction ratios? If A1, B1, C1 and A2, B2, C2 are the direction ratios, then A1 by A2 equal to B1 by B2 and C1 by C2. They are all equal, and there is nothing like equal to 1, right? So which means that the direction ratios are proportional. So basically what this means is that the length of the lines are proportional. Okay, now another very interesting case is when the lines are perpendicular to each other. Now what that means is that theta is equal to 90 degree, which means cos theta is equal to 0. So which means that L1 L2 plus M1 M2 plus N1 N2 is equal to 0, because cos theta is equal to this. So if the lines are perpendicular, then this is equal to 0, or if this is equal to 0, it means that the lines are perpendicular. Again, in terms of direction ratios, A1 A2 plus B1 B2 plus C1 C2 is equal to 0. So that is the case of perpendicular lines. I think that's enough for today. Bye for now.